Hello, everyone. Thanks for joining. I hope you don't get to sleep in this talk about testing after lunch. Let's start. So I am Daniel Horowitz. I am working on Spotify. I live in Barcelona, but I'm actually from Brazil. And before Spotify, I was working on N26. Let's go through the agenda. So we're going to go through some test fundamentals that they are the theory behind this talk. And there is like a couple of articles that we're going to go through. And then we're going to go through something that I call the classics, which is like, it's a few classic concepts, but they are controversial as well, to say the least. And then we're going to apply the fundamentals that we saw like on the first session and on a testing strategy. So it's a practical application based on an Android application for a mobile application. And we'll go through like some popular use cases and how to apply these things to solutions to day-to-day problems. So let's go through the test fundamentals first. So there's this article from the authors of Clean Code, which is Unit Tests Are First, from Tim Oettinger and Jeff Langer, that they talk about this acronym, the first, and they talk about test properties. And we're going to go through all of them and then with some examples as well. And then there's this other article from Kent Beck called Test Desiderata, which is an article explaining 12 test properties, but they also have a cool playlist on YouTube with examples as well, so I really recommend checking this out. You have the link there on the slides. So let's go through the first test property, which is the test should be fast, right? So test speed will determine how often you run the test. So this is crucially for your development cycle. And this will influence directly how you code. We'll later see some examples. Tests should be isolated. So each test should fail for a single reason. Tests with multiple assertions, they might difficult debugging, right? So you might not know why things fail or how to reproduce them. So there's also this recommendation from Dave Astel to have one assertion per test. And again, later, we'll go through some examples of that as well. Tests should be repeatable. You all heard about flaky tests, right? Flaky tests are non-deterministic. And if nothing changes, the test should always return the same result. So flaky tests, they ruin the confidence on your test suite, and this is really bad. Makes your team less productive. Like, you really want to avoid that. Tests, they should be self-verifying. So just like a Lego piece that you know exactly where it fits, the test should be clear whether it passed or failed. So frameworks like JUnit and others can mitigate you this problem. So for example, in JUnit, you know exactly what was the result, the actual and the expected. And that's how you see that a test is self-verifying. So the last letter of the acronym could be either timely. So you should always know what you're trying to build before you build it. And frameworks like TDD can help you on this one. So before actually coding, you should think about the behavior, write the test first, and then code the least amount of code to build that feature. So TDD can really help you inspire and find alternative scenarios. Or the T can also stand for thorough. So here we'll see also later that test coverage can help figuring out what pieces of code are untested. So let's go through test desiderata from Kent Beck. So in this article, he proposes 12 test properties. Not all of the properties must be present in every test, but the most important thing here throughout this whole talk we should always take everything that is here in this aspect. So the properties are trade-offs, and not having one of them should not be taken for granted. So if you prioritize something, you will get a cost because of that, and also some benefits. So one of the properties from test desiderata is that the test should be writable. So this is self-explanatory, so they should be cheap to write. Should be readable as well. So it should be comprehensive to the reader of the test. And also, while you are reading, you should think about the motivation of that test, right? So if it is readable, you will know why this test is there. Also, tests should be inspiring. So what does this mean, right? So passing the test should give you some confidence, right? That when you run your test suite, you should feel it should work like a safety net. And you should be able to change the code or delete some code based on your test suite. So this will also improve the team productivity. So whenever you run the test suite, it should mean that it should be ready to ship. That's the inspiring property. The most important one, and for me at least, is this one. And if you're going to get something out of this talk, I hope you'll get this one. So yeah, tests should be coupled to the behavior of the code and decoupled from the structure of the code. We'll go through an example of what does this mean. But yeah, this for me is the most important one. So what does it mean, right? So let's say we have this API, and we have we want to convert the vote average, the last field there in the JSON, to stars, just like you see on the right, below the title field. Okay, so then you build a simple function that converts a double into the stars emoji, right? So you do a math round, you divide it by 2, and you repeat the star emoji with that count. So after that, you write a test, and you say, okay, given the average, the vote average is 6, you should return 3 stars. And then this test passes, right? But while you were writing the function, you actually saw that in the IDE, it tells you that you shouldn't do math round, you should do round to int. So then you say, yeah, let's replace it. So changing the implementation didn't make the test fail. So in other words, the test is still passing because this test is actually decoupled from the test structure, but it's asserting the behavior. So that's what this property is about. In another metaphor, I guess you all know the Barcelona team, and they all play in this style called tiki-taka. So they're always passing the ball, and doesn't matter which player is playing, they always play with this same behavior. So if the coach changes the players, they keep playing the same style. And yeah, Pep approves this. So yeah, now let's go through the classics. It's controversial, spoiler alert. So yeah, I couldn't be talking about classic things if I don't talk about test scopes, which I guess you all saw this pyramid. I won't go through like much in detail here. I couldn't get much classical than this one. So yeah, it should have more unit tests than integration tests than end-to-end tests. But what I like to do here is give it like a little twist. And it's like a small adaptation for mobile projects. I used to work in a platform team, so sorry. So for most of your tests should run on your local environment, and least of them should run on emulators. So this could be like Roboelectric test or Snapshot. And then you have some real tests that run on real devices. This should be the least of your tests. And this is also making a reference to the fast property, because this will impact directly how often you run your test suites. your test suite. So yeah, this is something to keep in mind when writing, when thinking of the test suite as a whole. So there's also a polemic topic here. This one, fakes versus mocks. There is this article by Martin Fowler, Mocks aren't stubs. Then he explains not only mocks and fakes, but other test doubles. And these are the definitions of mocks and fakes. I won't read them. But yeah, he goes through when to use all test doubles and how to use fakes and mocks. But there's also on the Android community, there are some articles explaining trade-offs between fakes and mocks. And there's also like Zach Sveers talking about the productivity, right? The maintenance cost of writing mocks versus fakes. And also like a famous tweet by Jake Wharton explaining like how much time he saves when refactoring because he's not using mocks. But there's also my take. This is a very opinionated talk. Then for me, the mocks are normally tightly coupled to the code structure, while fakes are focused on the behavior instead of the implementation. Mocks, they could be costly to initialize, depending on the object that you're mocking. And fakes, they tend to be lightweight. And mocks, normally they are overused. There's also a very good blog post on the Google blog about this, about overusing mocks. You can take a look. And fakes, they are naturally reusable. We will see later that you can also reuse mocks. And mocks they have some use cases for mocks. We'll see also in this talk. But as a rule of thumb, you should take this into account. So let's go through one example of what Jake Wharton was talking about refactoring and how this saves some time. Right? So imagine you have a movies data source, and this data source fetches like a list of movies. So you have this use case that have the data source as a dependency, right? And then you write a test for the use case. And you see that you write this whenever function because you are mocking the data source. But then for the same use case, you write 5 more tests, right? So and this goes on and on. So let's take it into another perspective. So you have the movie module, like a Gradle module of a movie. And inside this movie module, you have the data source, the movie model, and so on. And then on your team, or on the Android team, other features are using the same module. And other features have a use case. And each use case has more tests. And this line of code is getting repeated and repeated and repeated. And whenever you're going to refactor this, you're going to go through all of those lines. So it's pretty overwhelming. So to mitigate this, you could eventually create a test module. And inside this test module, you have like a fake movie data source. You could also achieve this by using mocks, but fakes are more natural for this one. And also there is one aspect that I like to talk about, which is this line of code, the whenever. Because this is breaking the fundamental that we saw, that this is actually coupled to the code structure. So this shouldn't be working like that. Even if you create a test module and use a mock here, you still have this line of code, which for me, that's why I prefer to use fakes in this particular case. And yeah, if you do this, you will not leak the implementation, but also you have a reusable test. Okay, so let's go through more classic stuff. So we have meaningful naming. This could simplify the investigation and improve the test suite design. One assertion per test. We already talked about this. It also promotes single responsibility when testing. And also the given when then structure. So let's go through them one by one. So meaningful naming. I guess we all saw here or wrote a test like this, should fetch data, right? I did it before. So in the beginning, like having a longer name might seem weird, right? But then while we're reading this name, like for example in this case, you have given a 200 response. So it does ring a bell when you start thinking, okay, if I change the HTTP code, does the test change? Do I get another behavior? Should I write another test for that? Or in this case, we also have here with correct field types. So if I have an incorrect field type, do I get an error? So you start to think about these alternative scenarios. We also have like the given when then structure. So what does it mean? So you write the test in this type of structure, and once you do it over and over again, the reader he can navigate through the test much easier, and you know exactly what code blocks are doing what. So this is really helpful, especially like if you have a big test suite. Really improves productivity, and the navigation is much easier. And last but not least, the less classical thing, I guess the most controversial one, is test coverage. So this one, actually this is from also a Martin Fowler article, that you have the link there. And here, he's saying that you shouldn't use test coverage as a quality target. If you're doing it wrong. This is not what this metric is about. This metric is about finding untested code. So for me, I always build this metaphor that if you want to have a good test suite, like the metaphor is, you shouldn't try to change the world without making your bed. So if you actually want to have a good test suite, you should first introduce this metric into your code base and find where is the untested code. Once you do that, you can actually start the conversation, okay, I do have a good test suite or not. But if you don't know what code is untested, then you don't have a seat in the table, at least in my opinion. So let's go through some testing strategies and how to apply like all of those concepts into like a real world application. Okay, so imagine you have this movies application, and I'm going to propose an architecture here just to kick off the conversation. So imagine you have this data domain presentation, layers, and on the data layer you have a server, you have used retrofit, you have a data source, a repository, and in the domain you have your business logic and some use cases. And then on the presentation you have a view model, you have a screen controller, could be anything you like, pick your poison here. And then composables or views, and then the UI elements if you're using like system design library. So let's go through first the data layer. So some things that I like to do here is to fully test the network integration. We will see an example about that. Focus on the isolation, so keeping backend stuff separated from your code. This really helps. Your future self will pat you on the back if you do this. And in some cases, you want to propagate the errors correctly, like especially if you're working with polymorphic responses or server-driven UI. This is super important. We will also see like some applications of that. So let's think about this example. So we have a real simple API that receives a movie ID as a parameter and fetches the details of a movie, right? So then you create a network data source for this, and you inject the movie API, right? So then you write a test for that. And in this test, whoever saw a test like this, raise your hand. I did. I wrote one once, right? So you're mocking the API and then asserting the result, right? So what could possibly go wrong? So now you are thinking that this test is suspicious, right? So yeah, so then you run your application, everything's going well, and suddenly, boom, it crashes. And you're like, no, oh my God. Okay, so what happened here? Let's play a game. What was the problem? Can you find the problem here? So this is the data class, and on the right you have the JSON. So I'll drink some water while you think about it. Okay, let me help you. So do you see this field here? And this one? We are missing the serial name. So this test that we wrote is kind of worthless. And there is one way to mitigate this. So you could fully test a network. And how you do it, so one of the good approaches to use mock, for example, here, is to use convert this mocking of the API, and you can use a mock web server. So by doing that, you are actually testing the integration with the response parsers. You are using real responses. You are using the HTTP code. And this is great for polymorphic responses. If you're doing server-driven UI, for example, and you want to do different behaviors for different versions of the API, or if there is like an unknown field, how do you react to that? You can test those cases using this approach. So this is super handy. So let's go through the domain layer. So here, I like to focus on readable and isolated tests. Of course, doing more fixed and less mocks. And yeah, because this is the domain layer, it should be free of dependencies in every way. So let's see an example of the first point. So the tests, they should be readable and isolated. So what does that mean? So let's assume we have this use case to get high-rated movies, right? So you also inject the data source here. And this use case, it's only calculating the high-rated movies using just one field, which is the vote average. So everything is based on this field. All the logic is based on this field. So if it has a higher vote average than 8, is considered a high-rated movie. Right? So you have this whole data class, but you're just using one field to do this. So it's a very common use case. So then you write one test for that. And then you see here that I didn't wrote the, I put a question mark on the list, because then you think about, okay, so what should I put here? So I should just start instantiating the data class, right? So I start doing that, and you see how the tests start to grow. And I didn't even write the expected result, because you then write even more data classes. So what I propose to do here is to actually use some helper functions, like this one on the right, that has default parameters for all the values of the data class. And then on the test itself, you only use what is actually being dictating the logic of that function. So in this case, the vote average and the ID. So when you read the test, it's much cleaner. And to the reader, it's obvious that this test changes the behavior if you change the vote average. And this is clean and nice. Cool. So let's go through the presentation layer. So here, I was actually wondering if I should put this here or not, But then I saw the talk from yesterday, and I guess not everyone is doing UDF by now. But I would really recommend not using UDF, but thinking about your UI layer and making it testable. We'll later see an example of what does that mean. But it's really important when building a testable code base that you think about your UI layer. So when I say UDF, I guess if you go into the Google page and check how they implement UDF, you often find, like, if you're using Compose as well, you get a composable function, and the simplest thing you can do there is to get a composable function with just one parameter. So that's what you should aim for. Even if it's not a composable, if it's just like a custom view, you should aim to get like only one function that renders this parameter. This parameter will be the state, right, if you're using UDF. And this really helps you, also like in the migration to Compose, if you have a custom view, but also really helps you to make you test your view in isolation. You'll see later what I'm talking about. So presentation layer, also a very important thing to avoid flakiness, right? Everything here is about to avoid flakiness, because in general, like, you want to launch an emulator or a real device to test your presentation layer. And this by itself, it's already prone to flakiness. So you should try to avoid asynchronicity on the tests. And there is many ways of doing that. In this talk, I will propose to have like this different types of UI tests. So it's I call them pure UI tests. So you see it's not pure, but that's why it's in quotes, versus integrated tests. So yeah, the key concept here is repeatability, right? So pure UI tests, they test the view in isolation. They ideally map each state to one assertion type. And you do like simple view interactions, like a click on something and assert something, or just launch the view and assert another thing. So in integrated tests, you are testing the integration between all layers of your code. So you have a mocked server with a mock web server, for example, and you are testing the complete integration with the Android SDK, with the view model, the UDF, and then asserting the UI. You can do this with Espresso. You can do this with snapshot testing. I don't want to go into that specifically. It's not part of this talk, but keep in mind that it's very important to have a testable UI layer. So what does this mean in terms of testing, right? So on the left here, I hope you all can see. I'll go through them if you cannot see them. So here we are instantiating a state, right? And then we initialize the screen with that state. I purposely didn't put here what it's doing, because I want you to think about that this could be a composable function, it could be a custom view, whatever, but you just get the state. And it's very simple to set up this test, right? And then you do one assertion. So you are testing, here's like conceptually one assertion, but you are asserting just that state, and that's it. Here, I'm also using the robot pattern for doing this test. And then in contrast, you have the integrated test. So on the left, you saw there's just passing one state and asserting that this state is displayed correctly, right? But on the right, you're actually testing the integration between all the layers. And how this test is about, you get an error, and then you click on retry, right? So first, you don't register any mock web server, so you don't have anything, so it shows an error. You assert that the error is there, and then you register the API call, you click on retry, and you see that it actually, the UI recovered from this. So this is doing more stuff, is more prone to flakiness, and that's why you should keep in mind that this kind of test should also have less of those tests. And that would be it for me. It was actually quite fast.